Welcome to the Bare Metal Cyber Security Plus podcast. This series helps you prepare for the CompTIA Security Plus exam with focused explanations and practical context. For a companion study guide, check out the Achieve CompTIA Security Plus 701 Exam Success by Dr. Jason Edwards. It is the most concise and complete Security Plus guide on the market, built for busy professionals who want to pass the exam fast and on their first try. You can find this book and others at cyberauthor.me. Automation can transform your cybersecurity operations, but only if it's built on a solid foundation. In part 1 of this series, we looked at the complexity and cost considerations that go into automation design. Now, in part 2, we focus on long-term resilience. Specifically, we'll explore how to avoid single points of failure, manage technical debt, and ensure that your automation remains supportable and sustainable over time. Let's start with avoiding single points of failure. When we automate security tasks, we often connect multiple tools, systems, and workflows. But if any one of those components fails, and there's no backup or failover plan, the entire automation process can grind to a halt. A single point of failure is any component in a system that, if it fails, brings down the whole function. In traditional IT, we think of this in terms of hardware, like a server without a backup or a network without a redundant connection. In automation, it might be a script that depends on a single API, a central server that processes all alerts, or a scheduled task that can't recover from failure. Let's walk through a real-world example. A financial company uses an automation tool to respond to malware alerts by isolating endpoints through their network switch. This script relies on an API token stored in a single configuration file on one machine. One day, that machine is accidentally wiped, and no one realizes the token is gone. For several days, malware alerts are generated, but no endpoints are isolated. The automation didn't fail visibly, it just stopped working quietly. And because there was no redundancy or alert for failure, the team didn't find out until a post-incident review. The lesson here is clear. Automation needs monitoring, error detection, and redundancy. If your process relies on a script, make sure that script is backed up, version-controlled, and stored securely. If you depend on a cloud function or API, have a plan for timeouts, service unavailability, or credential rotation. Automation should log activity and send alerts when something fails or even when nothing happens at all, in case something silently breaks. One of the best ways to avoid single points of failure is through distributed automation. This means spreading automation tasks across multiple systems or nodes so that if one fails, another can take over. It also means building in retries, backup scripts, and alternative workflows. These don't have to be complex, but they do need to be intentional. Now let's shift to another long-term concern, managing technical debt. In software development, technical debt is what you accumulate when you choose a fast, easy solution today that may create more work or risk later on. In automation, this can take the form of hard-coded variables, undocumented scripts, one-off integrations, or shortcuts that aren't sustainable. The thing about technical debt is that it doesn't always look like a problem right away. In fact, your automation may run just fine. But as your systems grow, your team changes, and your needs evolve, those early decisions can come back to haunt you. Let's look at an example. A healthcare provider builds a set of custom Python scripts to automate user offboarding. These scripts disable accounts, revoke VPN access, and log the actions. But they're built by one engineer who stores the scripts locally and hard-codes several settings, like domain names and account thresholds, directly into the files. A year later, the engineer leaves the company. When the company changes its identity provider, none of the scripts work anymore. There's no documentation and no one knows how to update the code. The automation must be rebuilt from scratch. That's technical debt, and it can cost teams time, money, and momentum. To effectively manage it, automation should follow the same discipline practices as application development. This includes using version control to ensure all changes are tracked and reversible, conducting code reviews so others can understand the logic and structure, and designing automation in modular components to make future updates easier. Just as importantly, thorough documentation must be maintained so future engineers, whether new hires or your future self, can clearly grasp the code's purpose, dependencies, and troubleshooting steps. Another powerful technique is to template your automation. If you build one-off scripts for every task, your debt grows quickly. But if you standardize your logic, such as by using the same framework for all alerts, or by defining reusable policy modules, you save time, reduce errors, and make your automation easier to evolve. Managing technical debt is also about knowing when to retire automation. Not every script or workflow will last forever. If a process is no longer relevant, or if the system it supports has been replaced, shut it down. Old automation that runs quietly in the background can cause unexpected problems later. Now, let's move to the third and final consideration: ongoing supportability. Supportability is about more than just maintenance. It's about ensuring that your automation can evolve with your organization, that it can be monitored, patched, upgraded, and understood without relying on a single individual or outdated technology. Let's walk through a real-world scenario. A manufacturing firm implements a security automation tool that integrates with their log aggregator, ticketing system, and identity provider. It works well, but the vendor that maintains the tool stops supporting it. The team is left with a decision: continue running an unmaintained solution or rebuild the automation on a new platform. Either way, the absence of ongoing support makes the automation a liability. Supportability should be considered from the start. Ask questions like, will this automation still work if we change vendors? Can it be updated easily? Does it depend on third-party tools that are reaching end of life? Do we have the skills in-house to maintain it? One key factor in supportability is team knowledge. Security automation should never be the domain of one person. Even if a single engineer builds a workflow, others should be involved in testing, reviewing, and documenting it. Cross-training and shared ownership help prevent bottlenecks and protect the organization if someone leaves or transitions to another role. Supportability also includes lifecycle planning. If you automate a task today, how will you maintain it next year? Will the tool need patches? Will the script need to be updated for new APIs? Will the policy it enforces still be valid? By including these considerations in your planning, you avoid future surprises. And don't forget about testing. Regular testing ensures that your automation still works as expected. Changes in upstream systems, like altered data formats or access controls, can break workflows silently. Scheduled test runs, logs, and monitoring dashboards help you detect problems early and fix them before they cause real damage. To summarize, the long-term success of your security automation program depends on resilience, sustainability, and planning. Avoid single points of failure by designing for redundancy, monitoring failures, and distributing critical tasks. Manage technical debt by writing clean, maintainable code, documenting processes, and building with reuse in mind. And ensure ongoing supportability by training your team, planning for tool life cycles, and testing your automation regularly. These considerations aren't just best practices. They're the difference between automation that helps you and automation that hurts you. For the Security Plus exam, expect questions about automation, lifecycle, technical debt risks, and the consequences of poor planning. You may see scenarios involving broken workflows, undocumented code, or unsupported systems. Review terms like failover automation, modular scripting, lifecycle planning, documentation standards, and maintenance scheduling. They're all important in real-world security environments and highly testable on the exam. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.